Hello, everyone. And first off, I want to thank you for coming out this early on a Sunday morning, especially since many of you have been engaged in quite a bit of drinking here today and many days here prior at DEFCON. So thank you for coming out, making it out this early. Oh, a little louder? Is that better? Okay. All right, so today's talk is port scanning without sending packets. My name is Gregory Pickett with Hellfire Security. This is a short overview of the talk today. We'll start with how this all got started, or how I ran across this, followed by it's really not a magic trick. It is actually pretty straightforward. Next is loose lips sync ships, because ultimately it is what is advertised on the network that allows us to do what we're going to do today. And that next is catch me if you can. And finally, we're going to go back to the future, or how to ultimately mitigate this risk in an enterprise. Okay? So we'll start with, suppose you have this guy on your network. Okay? You really don't know what you're going to get, right? Well, and this guy is involved in some suspicious, possibly malicious activity on your network. How do you identify him? As an intrusion analyst, I have a three-step process in approaching events: characterizing the activity, profiling the hosts involved, and using that to make a determination, as well as to select next steps. When profiling, it is important for me to be able to identify my source, and that often begins with a host name. Names are one way to quickly categorize a host as an asset or an intruder, and can often lead to an easy identification of the source. For the most part, Windows hosts are rather easy. I just run NBT stat against the host and utilize the NB or NetBIOS name service to get a host name. But what about Linux? And what about Apple computers? And there are a whole lot more out there, different types of hosts like printers and a whole variety of different networking appliances. So this is the problem that I had as an analyst, and the question that I was looking to answer. Okay. Now, when I began to look for my answer, as an intrusion analyst, I'm looking at the network quite a bit. And I was examining the traffic that was flown to my interface, and I saw quite a bit of multicast that I was not familiar with. Now, the interesting thing about this multicast was that there was a tremendous amount of name information. And I was very excited, of course, because this was something that looked like it might be an answer to the problem that I was having. So I went ahead and did a little research on this multicast, and this is what I found. It is multicast, or it was multicast DNS. And the purpose of multicast DNS is peer-to-peer name resolution. It does have a history. Multicast DNS is the successor to AppleTalk name binding protocol, and it was eventually added to Apple's zero configuration networking initiative. Now, in addition to multicast DNS being part of this initiative, there was also an addition by Apple of DNS SD via multicast, or DNS service discovery via multicast, to the initiative to allow for peer-to-peer service discovery in addition to the name resolution. All right, so you can begin to see how this is going to look. The features, well, it is DNS, just running over multicast. Each host participating in multicast DNS maintains its own local domain, and queries and responses are sent to the multicast address over UDP port 5353, so that all participating hosts can answer queries sent, and all participating hosts can update their DNS cache with the responses that are returned. Okay, everyone is aware of the resolution that other ones are making. They're able to update their cache so that they don't have to duplicate that sort of activity. So you see a lot of flow of information, a lot of questions being asked and answered over the multicast. Okay? Now, there are a few basic operations that these hosts engage in. And this is important when we take a look a little bit about how this information flows over the network later on. First off, there's the probe. The probe basically is a situation in which there is a record that this host is going to contain, and it wants to establish this as a unique record. So it goes ahead and probes the network very much like a gratuitous ARP to make sure that this host, this record is actually going to be unique. Followed up by an announcement to let everyone on the local community, those participating in the multicast DNS community, that these are the records that I'm going to be holding, and these are going to be the unique records as well as any shared records. Shared records are very special. They are something we're going to be looking at a little bit more later on, and what we do rely on. All right. So once it's done this announcement, it then engages in the querying and responding to queries. All right. There's some information there. You can take a look at that later. These are basically specific properties about that activity to identify these sorts of operations. And finally, there is a goodbye. In the multicast DNS, there are unique as well as shared records. With unique records, not unlike traditional DNS, there is a time to live, so that if it's a unique record and the time to live expires, everyone realizes this is no longer valid and they dump the record. However, if you have a community where multiple hosts are sharing or all have this record contained on their host, would it expire if one member decides to no longer participate? Well, it would not, because you have a lot of other hosts out there maintaining that record, that shared record. So you want to make sure you say goodbye, so that the hosts out there know that you are no longer, you will no longer be responding for this record, no longer be responding to queries for this record. So it's a better way to drop out when you are sharing records with others. All right. I want to take a look quickly at some implementations of multicast DNS, and this is important when we look at some things later on. First off, it was all started by Apple, of course. The people who wrote the RFC are from Apple, but it was picked up by Avahi, and you find this service available as developed by Avahi in a great number of Linux distributions now. And then more surprising than that is actually there are a tremendous amount of implementations on networking appliances. I believe even TiVo is running this. So TiVo, you have network attached storage, cameras, any number of multimedia devices, printers, everything seems to be loaded with this now. Okay? Now these are just a little example of, I'm not going to talk about this really, but just looking at the records that are utilized or contained on these hosts. These are names for the hosts, and also service records. Service records to be utilized in the DNS service discovery. Okay. Also, in addition, there is text record. Unlike traditional DNS, a service record in multicast DNS is paired with a text record to give some information about how that service is configured for any host that wishes to utilize that service. They can look at that record and know exactly what they'll be dealing with. And then there is the H-info record, also utilized in multicast DNS. Okay. Now, before I move on, it is important to provide some additional information regarding DNS service discovery, as it is very important to what I'm about to show you. Hosts participating in multicast DNS are often participating in DNS service discovery as well, and this is a little bit about what these hosts are doing and what we'll take advantage of later on. First off, DNS service discovery is not unique to multicast DNS. It works over standard and multicast DNS. However, when it operates over multicast DNS, it is fully compliant. It is involved in continuous querying, because if a user wants to utilize, or a piece of software wants to utilize one of the services available out there, it wants to make sure that the list that it has to select from is fresh and is valid. So it's always going to constantly be querying and collecting responses in order to make sure that that list is valid. Now, it's important to keep in mind when you're dealing with multicast DNS of shared records, because shared records in DNS service discovery are basically you have a situation in which, let's say you have a community of hosts participating in multicast DNS and also DNS service discovery, and of those, let's say you have 5 that offer FTP services. Those 5 will actually share the pointer record for the FTP service. So when this pointer record, when someone actually queries the community for that pointer record, these hosts, these 5 hosts, will return a response to that query with a pointer, pointing back though, not the shared record, pointing back though, in each instance to their own deployment of it. So each host will point back to their particular instance, so that the software or the user making the selection can then have the records available, or can go get the records available to utilize any particular service that they decide that they want to use out of the ones that return a response. Okay, so these pointer records, well, shared among those 5, point back to unique service and text records that each host will then have to make available, so that you figure out about that service and to utilize it. Okay. All right. So when I saw this, I was pretty excited. I had an additional way to profile my hosts quickly, like I was often able to do with Windows hosts. And so I created a tool called MDNS hostname. The parameter there, it does a reverse lookup of the IPv4 address. I did repurpose some code that was designed for traditional or conventional DNS. So it basically just packages the same message, but sends it to UDP port 5353. So it operates using basically unicast legacy query to UDP port 5353 of the target. In addition, well, I was looking through these records that I was seeing over, being advertised over multicast. I saw a lot of other information, other types of records, and I began to identify some unique things about these hosts that were responding and delivering these records over the local network. So I said, well, let's go ahead and make a tool to take a look at those records, so I can maybe, once I get the host name, I can go ahead and find out a little bit more about the host, continue the profiling. So I made MDNS lookup. There's the parameters there. And now it's important to realize that it submits the question as given. If you fat-fingered or screwed up, you're out of luck. So if you don't get an answer, especially in situations when you were expecting an answer, go ahead and reevaluate that to make sure that your question is correct. And it also operates using unicast legacy query to UDP port 5353 of the target. I'm going to go ahead and do a demonstration of that real quick. I have a host here. Oops, that was weird. All right, so I'm going to start off by asking this host. Let's say this is one of the suspicious hosts that I'm investigating. So I'm going to ask it its name. And there it goes. It returned the name pretty quickly. And apparently its name is Ubuntu. I'm guessing you know what operating system that is, right? There's a lot of information in the name. So now let's go ahead and take a look at the host. Let's say that you may suspect it's a Linux box, but maybe you don't. Maybe it's some kind of generic name like Bob's Computer. All right, so you want to maybe explore what other records that this will respond to get a better idea of what you're dealing with. The same target. I'm going to go ahead and ask it if it's running the workstation service using the pointer record for that service. And I'm going to make sure that it knows that I want the pointer. Okay, there we go. It returned the pointer record. It also returned several other records. Multicast DNS is very, conserves bandwidth, and went ahead and packaged a couple other additional records in there that it thinks that I may want later, so might as well give it to me now in the same packet. It's giving me most likely the service and the text records to go along with it, so that once I point to that unique instance, I might ask for those records. It's going ahead and giving them to me now. The blank one is most likely NSEC, and that's because I didn't write any code to parse NSEC. So if it's blank, it's probably NSEC. And then finally, it went ahead and gave me the A record as well. So I can follow up and then directly address the service on that port. Okay, so quickly, we went over this, and I was, of course, when I did all of this, I was very excited because Windows boxes, of course, there's a lot out there, but there's a lot that are not Windows. And so this allowed me to address a gap that I had. Okay. But I had a question for myself here. I said, isn't this just flowing to my interface on its own? I never joined any groups. I never sent any packets on to anybody saying, add me to this group, the local router, add me to this group. So I said, okay, I could really, do some cool things with this, all this information flowing to me. All right? But what could I do? I also have a background as a penetration tester. So for me, this was great information gathering. All right? If there is a host advertising any sort of information, speaking at all on this multicast address, I immediately knew, of course, that it was live. Okay? And if there were any hosts out there that were responding to queries for services, I could pretty much write down, okay, that host says he has FTP. I'm going to take him at his word. Got FTP. This guy says he's got FTP. They're great. So I can take all this information and I can pretty much record it and, in essence, do a port scan. And that's what we'll be doing here in just a minute. All right, but there are some requirements. You must have active responders. Someone has to be offering out there. Someone's got to have services available. You also must be connected to the same switch as other resolvers. Someone's got to be out there asking. But if you must, you can join the group. And of course, it works best on a busy network because you need hosts out there asking a lot of questions so that you can collect the most answers. Okay? So first cool thing, host discovery. I'm all excited. I want to use this on the network. I want to see what's out there, what's advertising. So there are the parameters. And like any good discovery tool, you are able to give this, this utility a range that you're interested in. It reports on any host communicating to the multicast address for multicast DNS. It does not join the group, but it does have the option. So let's do a quick demonstration of that. I believe my traffic is still playing. I started some traffic at the beginning. Originally, I had some traffic that I recorded from a very large enterprise network. It's in the groups, the Fortune groups there. I won't say which group. But so I recorded that. But then I went ahead and listened on the hotel's wired network and with my tools and lit them up. So I went ahead and recorded, well, a crap load of, if I can say that, of packets off that network. And I'm going to go ahead and replay that. Or I actually have been replaying that. So let's go ahead and run this first tool, MDNS Discovery. There you go. Now this is being played back. So the rate of discovery is artificial. Okay? You do not have control when you're actually using it live on who's asking questions, when they ask questions, and who responds. So it can be very erratic, very irregular flow. But you can see there were a lot of hosts out there, weren't there, at this hotel. Advertising, here I am, here I am, come get me. All right. Is the sound still good? Okay. The end result, of course, is completely silent, passive host discovery. And the network guy is very unhappy. Very unhappy. Okay? But wait, there is more. Second cool thing, port scanning. Okay? Legitimate hosts performing, in essence, port scans, or actually you're asking one question for one service, it's more like a service discovery, with one packet. Couldn't I perform a port scan with no packets? Just listening. And that's right. So, multicast DNS, also running DNS service discovery, is two products in one. Is it magic? Nope. It's Apple's zero configuration networking. Thank you, Apple. So let's do this. DNS service discovery occurs continuously over the network. You want to make sure, for the user or for the software itself, wants to make sure that that list is fresh. So it's continually discovering this information out there, making sure that list is fresh for the software or for the user. So listen for it over multicast DNS, the DNS service discovery traffic. Don't rely on known service records. It's a very long list. It's too limiting. When a host responds to a discovery request, report all of the SRV or service record ports in its replies as ports open on that host. Okay? So, I'm still excited and coding late into the night, and I create MDNS scan. Like any good port scanning tool, it allows you to select a range that you're interested in, as well as any particular service ports that you're interested in. Currently, over 22 services, I should say currently 22 services, over 18 ports have been identified and using this method. Many more are possible, as I said, based on that exhaustive list that they have for DNS service discovery. There's one of the links that I have later on refers you to that list of all the different services out there that are supposedly available somewhere and findable using DNS service discovery. Now, this tool does not join the group either. Let's do a quick demonstration. And our good friends, the hotel here. I'm going to go ahead and leave it open. Here we go. This is, once again, an artificial flow rate, but you can see that there's quite a bit out there. Okay. Now, I'm going to go ahead and just show you one more. I'm going to stop this real quick and show you a demonstration that I recorded, because traditionally, when you're talking about penetration testing, you're talking about hacking in general, this is not the progression. Or I should say there is a certain progression you take in that process. And so I decided to go ahead and take these tools and utilize them in that process. So I utilize them basically in a typical penetration testing scenario. So I decided to go ahead and leave it open there, run MDNS discovery to see what hosts are out there, basically just to get an idea of what I have to work with, who's advertising out there. Once again, come get me. And you can take a look at that list, and there's not a lot of information on it, but I think that ultimately what you want to do is find out who is the most active, because it's very likely then they have the most services out there. Okay? So you go through that list, and when you come across one that interests you, either you're just randomly picking it out or because it's just got a lot of communication flowing over the multicast address, which hopefully translates or means there's a lot of services available. You can go ahead and stop that, and I stop that right here. And now that's a real flow there. So you saw live how quickly these hosts are communicating and advertising and how much they're advertising to you. All right, and so I'm going to go and do a scan, and I'm going to target that host, but leave open the ports because I kind of want to know all of what's available. And this takes a little bit of time, though, because I'm, once again, relying on someone to be asking the question out there so I can hear the answer. There we go. Nope, not yet. I am actually going to be stopping this halfway through because I am able to actually compromise a host. Utilizing these tools, very ninja, go in there very quickly. And since there was no active flows from me, I was able to get in there pretty quickly and take the host. And actually, at a certain point, there is a lot of information revealed that pretty much opens up the rest of the network for me. And I want to stop the demo before you guys see that. All right, so we got FTP, HTTP. Ooh, one of my favorites, Telnet. We'll let it keep going there because maybe we can get a better idea of what type of host it is by the ports that are open. Waiting. There we go, 631, I believe is IPP. Could be wrong, I always get those mixed up. So it possibly a printer then. 515 LPR, I believe. Looking a lot more like a printer. Did anyone here see the presentation on using the multifunction printers to own the network? Yeah, this is beginning to look a lot like that. 9100 PDL data stream. I'm pretty sure this is a printer. Okay. So I'm going to go ahead and try some of those services to see if I'm able to get in. And I'm pretty cheeky, so I'm going to actually use root. What the hell? Let's throw it out there and see if I'm able to get in. Ooh, what do you know? I'm able to get in with no password. Someone did not set the password on this printer. Wasn't Telnet open? It was. Wow. And what it tells me, I kind of already knew it was not set, the password. But there it is, and it gives you a couple of things to start out with there. The commands, and then of course, ooh, what do you know, dump the config. You probably didn't see that, it was rather fast. I'm going to go ahead and stop that right now. And that is because after I saw all the commands, just to get an idea of what I could do with the box, I like to play with these things, then I went ahead and dumped the config. And what I ended up seeing was the SNMP community strings, read and write. So one host, as it does in many compromises, gave me hundreds based on the advertising that I was seeing and some other observation that I was doing earlier. And this is why many compromises, no matter how minor, can ultimately be devastating. How one host left unsecured because no one really cared much about it, they thought it was pretty insignificant, can lead to a host that is significant. Okay? Very important. All right. So let's go ahead and continue here. All right, the demonstration. And I wanted quickly to take a look at comparing an active scan versus this type of passive scan. This is what our sensors see in a typical active scan, and that's our Nmap user there. It lights an IPS up like a Christmas tree. All right, this is not even all of the signatures that fired. And what do our network sensors see? There's me there. During this passive scan, they see absolutely nothing. Okay? So what does this mean? Completely silent, passive port scans. Okay? Network security guy, they are still very unhappy. Okay? Now, the reason why, of course, that this is not picked up is because any traffic flowing from your host would be very customary and wouldn't set you apart from others on the network, assuming you're not doing anything else, that would set anything off. If you're just doing typical web browsing, which is, of course, ultimately is just a DNS query and some HTTP traffic. So it wouldn't appear suspicious or malicious in any way, and if you're not exhibiting any sort of attack behavior, then of course it would not trigger any alarms. All right? And this does not do that. Now this does not get everything out there. All right? But we'll get you some of the most vulnerable hosts. Because if they did not take the time to turn off, or at the very least sanitize multicast DNS and the service discovery happening over it using DNS SD, then probably they didn't take the time to harden them. And we actually saw an example right there. And I'll have you know that I was able to repeat that example over and over and over again, without, of course, those SNMP community strings. All right. Okay. So as I said to myself, there was a lot more goodies, weren't there? All right. So what else could I do? Well, first off, we know from before that there are unique implementations. All right. If you look a little bit more at what's being advertised, you realize there are unique records, meaning that different device categories contain different records that are unique to that particular device type. Printers would have those printer records, right? Dealing with printer services, 515, 631, and 9100. But if you look even further, you realize there are unique sets. So that not only are you going to find a unique type of record on a device type, you are going to find actually a particular set that you will find only on a particular device type made by a particular manufacturer. So, could this be used to fingerprint the host? Yes. Yes, it could. If you have services, DNS SD UDP local, and you have workstation TCP local, and in particular the service record, then you're pretty much dealing with a Linux box. If you have the services DNS SD UDP local, AFP over TCP, TCP local, and that's the service and text record, on that host, and as well as device info, TCP local, text record, then guess what? you probably have an Apple host. Printers. Printers will have IPP, printer, and one of the three. And I find in particular that HP, those HP JetDirect cards, have all three. Now, if you have Black Armor 4D Info, the UDP local, Black Armor 4D config TCP local, service and text records, you're not only dealing with a network attached storage or NAS, but you're also dealing with one specifically from Seagate. IP cameras, if you have a host with the Access Video TCP local service record on it, you're pretty much dealing with an IP camera, and you are dealing with an Access IP camera. They're very specific in that name. All right. But there's actually a little bit more, because we talked a little bit about DNS service discovery earlier. And in DNS service discovery, there is that service record, which is not unique to multicast DNS and DNS service discovery over or via multicast DNS. There's also the text record, which always accompanies it. And that's very particular to DNS service discovery. So not only do unique record sets allow you to fingerprint participating hosts, but information in these record sets, specifically the text records, deliver configuration information to you. And here are some examples. We have a Linux box there in the text record for the workstation service. You have some information there, not a lot, but it does confirm that we're dealing with an Avahi implementation of multicast DNS on the Apple computer there. In the device info text record, there is, if you look right down in the what says model right there, it tells me exactly what model of Apple this is. This is a MacBook Pro 6.2. In the text record for those the text record for any of those printer services, it gives you the engine, it gives you the make, model, and version of the printer, it gives you the admin URL. They were nice enough to also give me the building it was in, and the user it was next to. Can anyone say social engineering? All right, so that's printer. And then for the Black Armor 4D Info records, the text record that goes with that particular service record, you get not only the device model and the vendor, well, we already knew it was Seagate from their unique record set that it offered, but it confirms it here. You also get the Web UI protocol and the Web UI port. Thank you very much. All right. So, someday, I wanted to create an MDNS fingerprint, build a database of identifying record sets, collect all information records and organize by host, all right? Match against the database, and then extract the configuration information so that I can return the identity and configuration information for each host to the user of that tool. Okay? But there are some limitations. Multicast. Routers between the recipient and the source must be multicast enabled. Okay? Not such a big limitation, after all, because this is most effective on your local network. So you're not really looking to go too far. You're looking to basically, rape, burn, and pillage your neighbors there. So you're not real worried about the router getting in the way. MDNS has some limitations as well. If you're talking about just querying, if you're just trying to get that name, you're just trying to just ask it what records it has or see if it has a particular record, there you are only going to get link local responses, and that's actually something that's designed into the protocol itself. And if you're talking about listening, which is where the real fun is at, you are limited by the layer 2 boundaries, the broadcast domain, as well as the layer 2 broadcast domain, as well as any VLAN containment that they've implemented. Okay. Now, our next step, of course, is to take a look at controls that are out there already and what they see. Can they handle this? Can they cope with this? First off, we already know that intrusion detection prevention systems don't do anything in this particular case. They don't see anything. Either ape is not going to really, well, it won't do anything for you because there are no sinks. There is no single host where all the traffic is flowing through for it to pick up and to light up on that graph. So, oh, sorry. There are no traffic sinks. There is no particular host that all the traffic is flowing through to show up on that graph, that either shows for you, gives you. And then, of course, there are no unusual flows to be picked up by NetFlow or StealthWatch. There's no surge in traffic to your host. There's no unusual amount of traffic to your host. There is no traditional type of worm activity where one host scans a whole bunch of them, and then one of those hosts starts scanning a bunch of, of hosts. there are no unusual flows. Your flows look like everyone else's flow out there, so it's not going to help you any. So ultimately, do they detect anything? No, they do not. And I've tried this, of course. I wanted to make sure I did it before I came here, because if I was wrong, I'm sure one of you out there would tell me right away. All right, so let's take a look next at some defenses. Okay, so maybe we can't see it. Can we stop it? Can it be stopped, or will it be stopped? Well, we'll talk about the hosts first. Antivirus, antispyware, antispam. Well, the threat is really not on the host, so there's nothing there for it to see. Firewall and port blocking. There is some option there. You can port block on the host 5353, but the thing is, there are a lot of hosts out there that are unmanaged. All right, I know. You wish they all were, but they're not. People bring machines in. Either they're machines that the company's purchased, but no one's decided to inventory. No one's decided to add to the system. They just cook them up there. We're only going to use it for a little while, right? And it's there for 3 years. And then, of course, there are a lot of devices out there that don't have end-user protection, so you know you have that gap there. So while it can limit your exposure a little bit, it's just not a good choice, and you really ultimately don't know what you're going to break when you start implementing this sort of things. And of course, the intrusion prevention system doesn't help you any, and application control, device control, and others aren't really just relevant in this case. Okay. All right. So, do these help any? No, they do not help. All right. So we then look at what is traditionally thought of your defenses on the network here. Firewalls. Well, we're talking about listening on your local network. And firewalls separate zones of trust. I'm operating within a zone of trust. So they would not be involved, really, Network access control. Well, traditionally, at least the first gen network access control is going to make sure that I'm patched and that I have an antivirus before I do all this to them, which is nice of it. Makes, it's very interested in my well-being. But it's not going to help you any here. Access control list, there's a possibility there. There is a good possibility there. But I think that access control list is probably not the best solution for this. But if you have nothing else, you can do that. But you do have to keep in mind, what do you break out there? All right? And of course, VLANs. VLANs are great. They're doing a great job out there. You can contain the problem a little bit by walling off your servers from your end user community. But a lot of what is advertising out there is devices in the end user community. So you really don't really completely solve the problem. You do limit it somewhat, the damage somewhat, but you really don't fully address it. So how about these? Not really. Not really. Some coverage there, but really not the best solution for this. What can we do then? Well, first off, we want to work with IGMP. Implement IGMP snooping. Make me join the group. Make me notify myself or announce myself in some way out there that make me announce that I'm going to be listening, that I'm participating. And if you can, authenticate group membership using IGAP if it is available, so that only valid or authorized listeners are out there participating, and of course, or resolvers. All right, and also if you can, track members. This is actually a lot harder to do. I looked for some management applications out there that maybe would be able to help report on this sort of on the memberships in these groups, but there wasn't really anything that I saw that was very easy. You had to basically go out to the routers and get a manual list there. Maybe run a script, something like that, to retrieve it. But track the members so that you do know who's participating and you're aware of what you have out there. And now, as far as multicast DNS is concerned, so the first one was basically to deal with people listening out there on the network. But how do you deal with people who are advertising? I think it's important to take the tools that I've developed, and because I know that's what I've been doing, to locate the MDNS responders out there. Disable the service if you can. And if you can't, harden the box, in particular the services that are offered. And make sure, if you can, also sanitize those records. Now, we know, of course, that the enterprise is full We do the best we can, full of very soft, tender, easy targets. And it's very difficult to get people to stay on top of hardening the host, make sure they're hardened properly. But at least if you are able to locate the ones that are advertising, you can prioritize your efforts, okay? Because they do present a much higher degree of risk because they're not just vulnerable, but they're telling everyone around them, hey, here, come get me, once again, with that. All right. So ultimately, the plan of attack is hunt down MDNS responders with these tools, remove them or harden them, and then implement any controls you have for multicast in your environment. The IGMP snooping, that's for IPv4, MLDV2, in those environments that have implemented IPv6. Implement, of course, IGAP if you have it, or any IPv6 multicast authentication mechanisms available, and of course, monitor. Find out who is out there participating. Okay. Before I go today, I'm going to mention a couple other protocols. The Simple Service Discovery Protocol, SSDP, and Link Local Multicast Name Resolution. These are Microsoft's answer. Doesn't always have an alternate answer. For zero configuration networking, or the zero configuration networking that Apple came out with. Both less developed, but still in use. I still see advertisements out there from SSD hosts utilizing SSDP. Okay. But my final thoughts are, hosts are now actively advertising their available attack services to anyone listening on the network. It's great for passive information gathering, but it can be controlled to limit your exposure. But ultimately, this sort of activity is not for the enterprise. The authors of the protocol say this in the RFC. They say this is for the home. This is for the small business. This is not for the enterprise. Unfortunately, as it occurs mostly in the vendor space, they're all competing. They're all trying to pile on, add on the most features they can. So they are doing this. They are putting these protocols and turning them on by default. They're putting these on their products, and I don't think people are aware of it, aware of this, and so they're putting these devices in the network, and they're advertising. So this is ultimately not for the enterprise. So you need to track this down, and you need to squash it before it becomes a problem. Okay. This actually is the conclusion of my talk. Thank you for coming today. There are a couple of slides. Thank you. There are a couple of slides here. The MD5 hashes of the tools, as well as the site to get the updates. I don't think that the updated tools are on the DVD, because I updated the tools and looked for a download, and there was none. So make sure you go out to that site. I'll put them up probably tomorrow. Go out to that site, get them the most up-to-date version. Some links if you're interested in reading more about it. So once again, this is the end of my talk. Thank you for coming.